Assalamualaikum and very good morning. So this is chapter 5, which is design for manufacturing, DFN, and design for assembly. Okay, what is DFM? So DFM is design based on minimizing the cost of production and or time to market for a product while maintaining an appropriate level of quality. So the strategy in DFM involves minimizing the number of parts in a product and selecting the appropriate manufacturing process. DFA, while involve making attachment direction and method simpler. So we'll look at DFM and DFA benefits. First and foremost, it can reduce part count, hence it will reduce the cost. If a design is easier to produce and assemble, it can be done in less time, so it is less expensive. Design for manufacturing and assembly should be used for the reason if no other. Secondly, it will increase reliability because if the production process is simplified, then there is less opportunity for the errors. And it generally increases the quality of the product for the same reason as why it increases the reliability. So in engineering, reliability means the ability of a system or component to perform its required function under state condition for a specific period or of time. Okay. DFM and DFA, it starts with the formation of the design team, which tend to be multidisciplinary, engineers, manufacturing managers, cost accountant, and marketing and sales professional. So it will start with the management first. So this person will lead to decide what type of DFM, what types of DFA they are going to implement. So the most basic approach to design for manufacturing and assembly is to apply design guideline. So you should use design guideline with an understanding of design goals. Make sure that the application of a guideline improves the design concept on those goals. Okay, look at the first DFM and DFA design. First, minimize part count by incorporating multiple functions into single parts. So look at this figure. So several parts could be fabricated by using different manufacturing process. Okay, so look at this part. It uses a different fabrication method. Okay, so ask yourself if a part function can be performed by a neighboring part. So dia hanya guna satu fabrication process. Okay, for this dia guna dua kali. So avoid this one. Alright, secondly, modularize multiple parts into single sub-assemblies designed to allow assembly in open spaces, not confined spaces. And the fourth one is easily indicate orientation for insertion, self-locking features or mark to make orientation easier. So in this part, okay, part should have self-locking features so that the precise alignment during assembly is not required. Or we can provide a marks or indentation to make orientation easier. Okay, next, we should design parts so they do not tangle or stick to each other. Okay, so just like in this figure. Next is a design part to prevent nesting, which is a specified component that can't nest tightly together. And okay, the other thing is distinguish apparently similar part. Distinguish different parts that are shaped similarly or hard to distinguish by non-geometric means such as coloring, such as color coding. Okay, and this is a standardized part to reduce variety. Okay, so means that you need to standardize part to reduce variety of operation choices and inventory burden. Okay, next, design part with orienting features to make alignment easier. And this one, provide alignment features on the assembly so parts are easily oriented. And design the mating parts for easy insertion. Design the first part larger and wider to be stable, and then assembly the smaller part on top of it sequentially. So if you cannot assemble parts from the top down exclusively, then you should minimize the number of insertion direction. Never require the assembly to be turned over. Okay, joining options. Okay, parts can be joined using fasteners, which is screws, nuts, and bolts, rivets, snap fits, welds, or adhesive. Designed to eliminate fastener and to place them away from obstruction. So this is the design to eliminate fastener and place fastener away from obstruction. By minimizing the number of parts is another approach. So the concept of the theoretical minimum number of parts was originally proposed by Boothroyd in 1982. Generally, during the assembly of the product, a part is required only when a kinematic motion of the part is required. A different material is required, and assembly of other part would otherwise be prevented. So if none of these statements are true, then the part do not need to be separate entities and may be combined. So it used the KISS principle, KISS, which is keep it simple, stupid. Okay. Okay. Another aspect of design for manufacturing is to make each part easy to produce. So the up-to-date DFM guideline for different process should be obtained from production engineer knowledgeable about the process. The manufacturing process are constantly refined. You can see this figure. Is it a handling issue about the symmetry of the shape of the nuts? Okay. Size very small, sharp, fragile. So the insertion issue. Okay, we look at DFM, Design for Manufacturing Design Guideline, which is first about injection molding, the fabrication of plastic by using the injection molding. Okay, what we should consider first, provide adequate draft angle for easier mold removal. Okay, the first one, provide adequate draft angle for easier mold removal. So I hope you still remember what is draft. So the draft angle is the amount of taper, okay, for molded or cast part, which is perpendicular to the parting line. So it can be measured in degree or millimeter over millimeter or inch over inch. So why draft angle in injection molding? Because it will reduce the chance of damage to the part due to friction during release agent during release. So if this benefit offer either direct or indirect overall production cost reduction. Second one, minimize section thickness. Cooling time is proportional to the square of the thickness. Reduce cost by reducing the cooling time. So for this, we should keep wall thickness to the minimum required for the part or product to function effectively. So this minimalist approach to part design means that less material will need to be injected into more cavities. Thus, we're reducing the injection time. Okay. So just remember to account for the required strength of your product wall and to adhere to best design practice for minimum wall thickness. Okay. So wall thickness will have a big effect on the cooling time. Next, we should Keep the rib thickness less than 60% of the part thickness in order to prevent void and sink. So maximum rib thickness should be in 0.5 to 0.75 of the nominal wall thickness to avoid creating of sink. Okay, so to avoid thin section of steel in your mold, the distance between the the ribs should be at least 3 times minimum. Okay, to the nominal wall thickness. So rib should have a draft angle of at least half degree per side in order to accommodate easier ejection from the mold. Right. So avoid sharp corners. They produce high stress and obstruct material flow. The inside radius should be at least 50% of the nominal wall thickness. For the outside radius should be the nominal wall thickness plus the inside radius. Okay. So accordingly, it is about 150% of nominal wall thickness. So sharp corners at the base of bosses and rib can be stress concentrators. The edge where a boss meets the nominal wall should be reduced to reduce the sharp corner without increasing the wall thickness enough that it creates a sink problem. Provide smooth transition and avoid changes in thickness when possible. Keep section thickness uniform around bosses and use standard general tolerance. Okay. So minimum thickness recommended is 0.25 inch and for round interior and exterior corner to 0.01 to 0.015 in radius. So this is the standard thickness variation, which is 0.005. Rotational molding process consists of 6 steps, which is a predetermined amount of plastic, powder or liquid form is deposited in one half of a mold. The mold is closed, the mold is rotated by axially inside an oven. The plastic melts and forms a coating over the inside surface of the mold, and the mold is removed from the oven and cooled, and the part is removed from the mold. This is a rotational molding. Okay, vertical wheel machine, double machine. Some advantages of rotational molding and the limitation. Okay, you can read and go through it by yourself. So material, polyethylene, PC, nylon is good chemical resistant, abrasion, good toughness and stiffness, and it is suitable to use by rotational molding. Okay, for rotational molding, nominal wall thickness, polycarbonate wall thickness is typically between 0.06 to 0.375 inch or 0.1 to 5 inch being an ideal thickness. So polyethylene wall thickness is in the range of 0.12. Okay. This is the design for ease of blanking for sheet metal forming. The sheet metal forming is actually working generally incorporates cutting and forming operation on thin sheets of metal. Okay, typically the thickness of sheet metal is between 1/4 inch and 1/64 inch. So there are different types of metal forming operation, which are bending, shearing, blanking, punching, and stamping, and etc. Okay, so this is type of shear metal bonding. So shearing, what is shearing? Shear means separating material into two parts. Okay, so the form operation should have a minimum height of 2.5 the blank thickness. So basically, this